Okay. Um, Import. Let me see. Yes, formula sheet. Import data sheet. Then import this question. Okay, import that question. Seems like you're back.
Okay. I am back.
Okay. We're gonna screen again.
Yeah, I can.
Okay. Um, okay. It says 2 point charges A and B placed 3 meters apart. Okay. The charge on A is positive 6 multiplied by 10 exponent minus 6. 10 exponent minus 6, it's microcoulombs. Okay. And the charge on B is 3 - 3 multiplied by 10 to the exponent of minus 6 coulombs. Okay. Now P is a point 1 meters to the right of charge B. Okay. Now define the 10 electric
Okay,
field at the point. Yes, I'm
the
listening.
question from which
Oh,
year?
okay. It's Houghton. It's Houghton.
Prelim.
Yes,
Prelim.
Houghton prelim. Yes, 2024. So okay, can I write?
Yeah.
I'm trying to record this also, so I'm avoiding it being long. Now it says we must define the term electric field at a point. So we are going to say the electric field, electric field. Okay, electric field at a point. At a point is the net electrostatic force experienced Okay, so yes, when we talk about the term electric field at a point, we are talking about the electrostatic force experienced by a positive unit charge that is placed at that specific point. All right, that is what we call an electric field around a point. Now, they want us to calculate the net electric field at point P. So, what will be the net electric
Follow
field?
me.
Or you want to write the question?
Please go. Yes,
Or wait, do you want the question or the definition that I wrote?
both.
Like this is fine.
Yeah, it's fine. Go scroll ahead because I can't see.
Like this.
No. Yeah. Yeah.
Okay. All right. Now the second point, which is 7.2, they want us to calculate the net electric field at a point. So basically, we are going to focus on point P, which is this point over here, right? So now for us to calculate the net electric field point on that, so it is going to be the electric field that is applied by A, or the electrostatic force, electric field applied by charge A on P, also electric field applied by B on P, right? So that is the net electric field on what? On P. So now we need to put that into an equation format. So let's see what is it that we are going to get. Now, which formula am I going to use? Now we can go up there and check which formula we are going to use. So for electric field at a point given the charges, we are going to use this one. If you're given a force, you can use this. But under our circumstance, we are given a charge. So this is the equation that we are going to use. E is equals to KQ divided by R squared. Okay. Then we will go and write our 7.2. Um, so it's going to be our 7.2. Now on our 7.2, because of we are talking about two charges, so we are going to say E net, which means the net electrostatic field, okay, is equals to, now the electrostatic field due to charge A minus electrostatic field due to charge B. All right. Now we
Wait,
substitute.
you said electrostatic force on charge A.
Yes, electrostatic field, not a force but
Wait,
a
I don't
field.
get it.
Okay, let me explain. I'm going to go back up to the question and try to explain. Okay. So what's happening here is that the question, number 7.2, sorry, is saying that we must calculate the net electric field. So not electrostatic, but net electric field at point P, right? So what is the net electric field at point P? The net electric field at point P, it is electric field applied by charge A on P. So charge A as it is applying electric field there. What is an electric field? So as A, because it's a positive charge, it sends signals or electric fields like that, waves like that, right? So as it is sending them,
Mm-hmm.
point P experience these waves, right? So it is called an electric field strength at point P. So it is going to experience the attraction due to these
Yeah.
waves reaching point P. Similarly, a B but B is a negative charge. So negative charges, the field goes inside, right?
Mm-hmm.
The field goes inside. So can you see that P also experience what? The field by B, all right? But now the problem is, can you see that
Yes.
the B's, they go there, whereas the A, they go there. So they do what? They oppose one another. Can you see?
Mm-hmm.
Good. So then when we write it in an equation format, that's why we are going to say that
Wait, you said point pick any angle left.
no B, yeah, the net electric field on
Oh.
B, di tsena ka mahara the charge here B like this because it's negative charge.
Mm,
And then A, because it's a
yes.
positive charge, the waves that in the like this.
Okay.
So because of the and in the
Mm,
fatal P, it experience because P come right, it experience a dia so why one.
mm, mm,
Whereas P experience at a B dia guy, ditla so. One so dira dia kwa,
mm,
mara tsela dia kwa. So they oppose one another. Why tlhaloganya?
mm. I get it now.
Okay. So now, ha etla mo equationeng, re tlo re the electrostatic field, the net electrostatic field at a point, in this case, point P, elegantly the electric field at A minus electric field at B. Why minus? Because they oppose one another. So they subtract one another.
Mm,
Okay. So then
mm,
we continue with the equation. We continue with the equation. Then over, so I'm gonna write it further left for the sake of space. Then E net, etlole kana le K QA divided by R squared. So this is electric field due to charge A, hence QA. Then minus K QB divided by R squared. So I'm going to go back to the formula sheet for you to understand why getting with so, right? Because the formula that I'm using, get this formula over here. Wait, one. Okay,
Why
good.
are we not adding?
That's a very that's a very good question. Simply because this one here to the right, this one, but we are looking at them from a point of reference here Q, from position here P. I mean, A here to the right, but B we visiting the right to the left. So they are minus R.
Okay.
Understand? Because we see them with reference to point P. That's why carry Piao. Okay. So um, let us continue. Now, K it is a constant. K it is a constant value at the 9 times 10 exponent 9. I think it is called, is it Planck's constant K? Um, no, it's Coulomb's constant or Planck's KLI, yeah, light, if I'm not mistaken, light energy. So this is Coulomb's constant. So it is 9 multiplied by 10 exponent of 9, then multiplied by the charge of A. So the charge of A was 6 times 10 exponent minus 6. So divided by R squared. So what was the distance? So the distance is 3. Yeah, that is positive 6. The distance is 3 meters. Then here the distance is 1 meter with a charge of minus 3. So the distance here it is 3 meters. So it will be 3 squared minus 9 times 10 exponent 9. Then on the second bracket, so it's going to be 3 times 10 exponent minus 6. Now everything will be divided by 1 squared.
Why are you not putting the negative mod 3?
Okay, good. Um, Now it now goes back to the definition. All right. What is
Positive
electrostatic
charge.
field? Is able to pay unit positive charge. So that's why we don't put the negative there. Happiness.
Okay. Does this apply to all? Okay, the electrostatics.
Yes. It applies to all of them. All of them. Even your F is equals to Q1, Q2, you don't put a charge there.
Okay.
So then yeah, Babokai, yeah, please let us press together on a calculator. Yeah, well, I'm too big to fit the pattern with a calculator. You go press on. So, okay. Uh, I get minus 23, 625. Please verify. Then, because it's E net, it will be newtons per coulomb. So so if you can check, I took A as positive and A here guy to the right.
Wait,
Yes, I'm listening.
why am I getting negative?
You got negative
I'm
what?
getting negative
Let's press
21,000.
together. This is 9 times 10 exponent of
Okay, let me
8.
restart. Okay.
Oh, I think I know. No, no, you are not wrong. You are not wrong. I did this question, Maban, or again, like,
What did you do?
no, I solved it, Maban, this question. That's why it didn't take time. So I think I cramped this value. Why did they
Mm,
put,
network.
okay, you know what I pressed in on my side?
Mm,
The length should be this value plus that value. So F4. Now on my mind subconsciously, ke hirile mara mo ke ngotse 3 more.
it's supposed to be what, 4?
Yes, because P it is 4 meters away from A, but P it is 1 meters away from B. Can you see it?
Wait, P is, oh yeah, 4 meters.
Away from A, and but it is also 1 meter away from B. So this value is to the one 4 and 1 is because P it is 4 meters away from A, and then P is also 1 meter away from B.
Mm. So the electron on the B is the distance stays the same as 1 squared,
It is what?
right? Yeah, I chin now 1 squared anger.
Yes, yes.
Inshallah for 1. Got it.
How much?
Negative 23,625.
Newtons per coulomb, right?
Is that what you got?
Yes, that's the same on my side. So now, uh,
So
yeah, I'm listening.
won't I be penalized if Gengwala answer so instead of um writing it in the scientific form from the calculator?
Mm, I don't think you will be penalized for scientific format, but this is not really the final answer. So you need to remove this and put direction. You need to remove negative. Okay. So what
Mm,
you need to do? Remember, we look at everything from the point of view. Yeah, yeah, yeah. P. All right. So P. Re A is positive. So A ya guy to the right. I get P. A here to the right. And then B, the waves is at India guy
mm,
to the left. And then rare B era B had a substitute that are in negative. So our final answer is negative. So ra
mm.
diaco let's I think la B, and then B the waves at India to the left. So that means this answer. This answer it must
To
be
the left.
23 is 625 newtons per coulomb to the left. Because the wave is a b there to the left. Then the answer must be like this. So you can write it as 23.6 times 10 exponent 3. I think nobody will care that much about it.
Mm.
Okay, now um 7.3. Now a proton is placed at point P. So point P, it is no longer a point in J. A P now there's a proton there. So a proton has a charge and it has mass. So that's why they're mentioning you now. A proton has been placed there. Calculate the magnitude of the initial acceleration of the proton if the mass of the proton is this. Okay, now what do we do? Number one, a proton and an electron, they have the same charge. It is just different in size. Okay, so now we will go to the formula sheet. Then ranyagana le charge of an electron. So electron charge, the second last, can you see?
Yes.
So alpha minus 1.6 times 10 to the power of minus 19. But a minus because k electron. So nke ele proton e tlo ba
Mm.
positive.
Yeah.
Okay. Therefore, let us write it. It's 7.3. So on our 7.3, we're going to use an equation because the question, once a question area, calculate the magnitude of the initial acceleration. So the only way I can get acceleration, A rank sense, I'm gonna use the equation of F net equals to ma, right? So for me to get the force, I must use this equation. Which equation? For me to get the force, I must use this equation because I've got electrostatic field, then I've got the charge of an electron from the formula sheet. So ke shota ka force. So I'm gonna get a force. That's why I'm taking that equation.
Yung is low for one, yo.
I'm okay. I am recording the session on my side. I think it can help. Get was another link just after, maybe within 30 minutes after the lesson, because get will upload the go YouTube gear unlisted, so that only you can see it. Is it
Okay.
is it fine?
Yeah, it's fine.
Okay. Um. So we're going to use equation A ring E is equals to force divided by Q. Okay. Then electrostatic field at Q, look at this one over here. So retro 23,625 is equals to an unknown force divided by the charge. So the charge, it will be 1.6 times 10 exponent minus 19. Okay, this charge is from an electron. Now,
So you're not there and we don't put a negative in front of it.
no, no, you don't because I get ke charge a proton, a positive. Just that electron le proton, they are like a charge. Difference got M way positive.
Mm.
Okay. Then from here we
Okay.
make force the subject of the formula. Then we multiply this 23 625 by 1.6 times 10 exponent minus 19. So I've got a certain number, 3.78. 3.78 times 10 to the exponent of minus 15. Because of its force, it's going to be newtons.
Mm-hmm.
Then we go to the formula for Newton's second law of motion. So rotor F net equals to ma. So then we substitute F net equals to ma. So we have F net 3.78 times 10 exponent minus 15 equals to the mass. The mass of a proton they gave us, but again 1.67. We want to get on the question. But again
Mm-hmm.
1.67 multiplied by
Yeah.
10 exponent of minus 27. So it is 1.67 times 10 exponent minus 27. Then acceleration, we don't know it, so we put it aside.
Mm-hmm.
So what do we do then? We can now divide by 1.67 times 10 exponent minus 27 both sides. 1.67 times 10 exponent minus 27. So this will cancel that. A will become the subject. Now what is the value? So answer over 1.67 times 10 exponent minus 27. So according to my calculator, I got 2.26. The units will be meters per second squared. Okay, now let's see. That was question 7.3. Now 7.4. If an electron was placed at point P instead of a proton, how would the acceleration of the electron compare to that of the proton? Okay, now to answer this, we need to understand the relationship between acceleration and mass. So we are replacing an electron, I mean a proton ka electron, of which electron and a smaller mass, right? So now when we answer it on 7.4, the acceleration will be larger. So I'm gonna say larger acceleration. Why will it have a larger acceleration? Because the mass because the mass of electron is smaller. Of electron is smaller. So you can also reference the equation that acceleration is inversely proportional to 1 over mass.
Mm.
Okay, so this is how they would expect you to answer this. Then you would get 2 marks to show. Okay,
Okay.
all right. And then this is the next question that I planned. Oh, hey, what? Oh yeah, this is the next question. Um, that I planned to do with you. So, are you going to copy the question down, or must I quickly do it?
Now you can continue. I'll write it down after.
Okay. 2 point charges Q1, Q2 are placed 30
Yeah,
centimeters apart.
yeah, promise. Yeah, those people. Because it's
This
a
one
different question.
this one looks like it's a 2019 SC meaning it's a June paper. It's a June senior. It's like how do they call this one, man?
Which one? NSC?
Yeah, it's an
What?
NSC June. NSC June. NSC June. Corona le bana ba le gore a kere he le na le ngwana di-exam bona ba bangwe ba di itse cause na ba sa pass go botlhe.
Mm.
Ke yone exam a teng. So I don't know how to explain it, but it's a full exam, but by ngwana ka June. So it's 2019 June.
I feel the relators.
You don't wanna be there, eh? Please. Okay. So it says 2 point
You continue.
charges Q1 and Q2 are placed 30 centimeters apart along a straight line. Charge Q1 equals to minus 3 times 10 exponent of minus 9 coulombs. Now, point P, where's point P? Right there, left point P. Oh. Now, point P is 10 centimeters to the left of Q1. So, as shown in the diagram below, the net electrostatic field at point P is zero. They're giving us very important information here. The net electrostatic field at point P is zero. Now define the term electric field at a point. I'm not going to do it because I just defined it on the previous question just to save time. Okay. Now state giving reasons whether charge Q state giving reasons whether whether point charge Q2 is positive or negative. Okay. Looking at this, charge Q2 is positive. Now, why is it positive? Because they told us that the net electrostatic field on P is zero. We need an opposing charge to cancel that one. If it's in the minus 3 and minus 5, they can't cancel each other because they go to the same direction. Okay. So now, if you were to write it down, the answer, let me just do this. Please give me a second. That will be 7.2. So we will say Q2 will be positive. Why is Q2 be positive? So since the net, since the net electric field uh, since the net electrostatic electric field, so I will leave it like this. Since the net electric field due to P is zero, right? So Q2 must be positive, must be positive to oppose Okay, so that is the reason I'm going to give the. Now, where was I now? Okay, now 7.3. Calculate the magnitude of charge Q2. Calculate the magnitude of charge Q2. So to calculate the magnitude of charge Q2, I'm going to make use of the electrostatic force at P. Let me see.
Mm-hmm.
Okay, calculate Q2. Okay, no problem. So we have charge Q1 there. All right. So what I'm going to do is that on 7.3, I'm going to say E net, and then this is due to point P equals to 0. All right. So E net, it consists of two things. It consists of K Q1 over R squared minus K Q2 over R squared. One of these needs to be positive, one of them needs to be positive for them to be 0, right? Now, we can just transpose the other one to this side. Therefore, we will have Q1, KQ1 over R squared equals to KQ2 over R squared. So we don't know Q2, but we know Q1. Then we substitute. So we're going to have 9 times 10 exponent positive 9 multiplied by, was it 3, is multiplied by 3 times 10 exponent. Okay, times 10 exponent what? Minus 9. Okay. And then divided by the distance. The distance was given to us in centimeters. So we need to convert this distance in meters. So the distance from Q3 to P, it's 10. 10 is 0. 0.1 in meters. So it's going to be 0.1. Then
Mm.
we put a squared. Then equals to, oh, I can't because of the page. Um, then equals to, now this one, we don't know charge Q2. So we only put what we know, multiplied by Q2
Mm-hmm.
divided by the distance. So what is the distance there? Um, 30 plus 10, 40. So it's 0.4. So 0.4 squared. So now you must solve for Q2. So basically what you're going to do, you're going to multiply by this, then multiply by the day. So let us press our calculators. Q2 will be equals to something. So let me press also. Okay, I get 4.8 times 10 exponent minus 8 coulombs. What did you get?
I calculate. I'm still calculating.
I go button little.
Hmm?
Okay, mo the button little fela good it. This topic. Once you do cross multiply, you leave Q on this side, I get you. So bear in mind.
Yeah, I got 4.8 times 10 to the power 10. Ah, why we're not really negative
Where?
8 on your Q2, your final answer?
How?
You got to the power negative 8, I got to the power 10. So
Positive 10.
I don't know what I did wrong.
Let's look.
That's what I got.
This is positive 9, I get more. I had to check. Uh, we'll get a
Yeah.
positive 9.
Mm.
And then this is negative 9.
Uh, yeah.
Okay, this is positive 9.
Oh, yeah. I see my mistake. I got it.
Okay.
I did negative 9 instead of positive.
All right. Okay, so um why doesn't it want to scroll now? That was 7.3. 7.4 state Coulomb's law in weight. I'm just going to mention it because I'm recording, because I'm looking at the time. I need to hop to another session. Okay. So Coulomb's law in weight, it is the electrostatic force between 2 point charges. Um, the electrostatic force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the squared distance in between them. Okay, that is 7.4. Now for 7.5,
Yes.
calculate the magnitude of the electrostatic force exerted by Q1 on Q2. Hmm. Okay, let me just. So this needs to be
You know, I
F.
can't see your screen anymore.
Oh, serious?
Hmm.
Evan.
Okay, now I can.
Okay, let me see
And
this.
it's slow.
I think it was network related. Okay. Let me just try to do this so that when you get the recording, the answer is there, right? This we got 9 times 10 exponent minus 9. Ups, not minus 9, but positive 9. Okay. Then 3 times 10 exponent minus 9. So I hope you grammar this trend. Normally, the definition of Tsankayona, you are most likely going to use its equation. So be aware of that for physical science, right? So divided by r squared, what is r? Um, in between the 2 point charges, they are 30 centimeters apart from one another. So it's going to be 0.3 squared. Okay. Um, please, you will fill this in. You will fill the answer in. Just punch it on a calculator. Then let me go up and see. Um, Now, question 7.6. The two charges are now brought into contact with one another, right? That is question 1.6. So, since the two charges are brought into contact with one another, okay, the answer to here got it. It's 1, comma 4, 4, times 10 to the exponent minus 5 newtons. Now, since the two charges are brought into contact with one another, that is 7.6. So, what will happen? So, the question, does it want me to calculate? Okay, then separated. The learner draws an electric pattern. Is the correct? Yes,
Now I
it is
can't see your
correct.
screen anymore.
Let's see. I think it's network related. Okay, okay.
Because it keeps on coming.
Yes. So I think I will terminate the class. We can terminate it now. I'm going to send you these notes shortly after. Okay.
Okay,
I need to join
another class.
yes. Sharp.
Sure.